Hey people, it's Iron Stokey. Now one of my subscribers told me about this, so I wanted to share with you. Now this is from The Guardian, but I'm going to put up a few different articles to give it some good coverage in the description. So powerful antibiotic discovered using machine learning for the first time. Machine learning is just artificial intelligence. Team at MIT says halicin kills some of the world's most dangerous strains. A powerful antibiotic that kills some of the world's most dangerous and drug-resistant bacteria in the world has been discovered using artificial intelligence. The drug works in a different way to existing antibacterials and is the first of its kind to be found by setting AI loose on vast digital libraries of pharmaceutical compounds. Tests showed that the drug wiped out a range of antibiotic-resistant strains of bacteria, including Acinetobacter baumannii and Enterobacteriaceae, two of the three high-priority pathogens of the World Health Organization ranks as critical for new antibiotics to target. In terms of antibiotic discovery, this is absolutely a first, said Regina Barzilay, a senior researcher on the project and specialist in machine learning at Massachusetts Institute of Technology, MIT. I think this is one of the more powerful antibiotics that has been discovered to date, added James Collins, a bioengineer on the team at MIT. It has remarkable activity against a broad range of antibiotic-resistant pathogens. Antibiotic resistance arises when bacteria mutate and evolve to sidestep the mechanisms that antimicrobial drugs use to kill them. Without new antibiotics to tackle resistance, 10 million lives around the world could be at risk each year from infections. By 2050, the Cameron government's O'Neill report warned to find new antibiotics, researchers first trained a deep learning algorithm to identify the sorts of molecules that kill bacteria. To do this, they fed the program information on the atomic and molecular features of nearly 2,500 drugs and natural compounds and how well or not the substance blocked the growth of the bug E. coli. Once the algorithm had learned what molecular features made for good antibiotics, the scientists set it working on a library more than 6,000 compounds under investigation for treating various human diseases. Rather than looking for any potential antimicrobials, the algorithm focused on compounds that looked effective but unlike existing antibiotics. This boosted the chance that the drugs would work in radical new ways that bugs had yet to develop resistance to. Jonathan Stokes, the first author of the study, said it took a matter of hours for the algorithm to assess the compounds and come up with some promising antibiotics, one which the researchers named halicin after Hal, the astronaut bothering AI in the film 2001, A Space Odyssey, looked particularly potent. Correct me if I'm wrong, but in that film, doesn't Hal go crazy and try to kill the astronauts? Though maybe I've got that wrong. Writing in the journal Cell, the researchers described how they treated numerous drug-resistant infections with halicin, a compound that was originally developed to treat diabetes, but which fell by the wayside before it reached the clinic. Tests on bacteria collected from patients showed that halicin killed Mycobacterium tuberculosis, the bug that causes TB, and strains of Enterobacteriaceae that are resistant to carbapenems, a group of antibiotics that are considered the last resort for such infections. Halicin also cleared C. difficile and multi-drug-resistant Acinetobacter baumannii infections in mice. To hunt for more new drugs, the team turned to a massive digital database of about 1.5 billion compounds. They set the algorithm working on 107 million of these. 3 days later, the program returned a short list of 23 potential antibiotics, of which 2 appear to be particularly potent. The scientists now intend to search more of the database. Stokes said it would have been impossible to screen all 170 million compounds by the conventional route of obtaining or making the substances and then testing them in the lab. Being able to perform these experiments in the computer dramatically reduces the time and cost to look at these compounds, he said. Barzilay now wants to use the algorithm to find antibiotics that are more selective in the bacteria they kill. This would mean that taking the antibiotic kills only the bugs. This would mean that taking the antibiotic kills only the bugs causing an infection and not all the healthy bacteria that live in the gut. More ambitiously, the scientists aim to use the algorithm to design potent new antibiotics from scratch. The work really is remarkable, said Jacob Durant, who works on computer-aided drug design at the University of Pittsburgh. Their approach highlights the power of computer-aided drug discovery. It would be impossible to physically test over 100 million compounds for antibiotic activity. Given typical drug development costs in terms of both time and money, any method that can speed early-stage drug discovery has the potential to make a big impact, he added. Well, I hope you've enjoyed that, and we'll leave different articles and descriptions. You can read up on it. Please comment, rate, share, and subscribe. If you would like to support this channel, I'll leave my GoFundMe in the description and I'll leave my Instagram there as well. Peace.